Welcome. So in this video, we're going to be going through solution of trigonometric equations. Let's first go through the procedure. Step 1, rearrange your equation to have one trigonometric ratio as the subject. Step 2, find the acute angle / reference angle, ignore the sign. Step 3, use the sign to determine which quadrant the angle appears in. Step 4, modify the given domain if required. Step 5, find all angles in the given domain and simplify as required. So at the moment, that's not going to make much sense, but once we jump into some examples here, it will make perfect sense. So let's start with the first one here. It says solve sine of theta is equal to a half, for theta is an element of 0 to 2 pi. Okay, what should we be visualizing when we're given a question like this? Well, let's just bring up a little PowerPoint here, and we can really just visualize what this question is telling us. Let's first draw some axes here and draw in y equals sine of theta. And we know that's going to look like this. And we know that sine of theta has a period of 2 pi, which is really good because, as you can see here, the domain is 0 to 2 pi. So that's just going to be really helpful. But we're going to have to deal with other questions later on when the domain is different. But for now, let's just relax. It's nice. Now, we also have this equals to a half. So what I'm going to draw is y is equal to a half. Now, hopefully you can now visualize what this question is asking of us. It's asking us to find the intersection points, the theta values of these intersection points. So how do we do this? Well, to do this, what we're really going to be doing is using our unit circle. And I'm going to be showing you some helpful hints and tips on how you can use the unit circle to effectively answer these trigonometric equations. The first thing that we do when we are given a question like this is we look at this, and as you can see, it's sine. We know that sine corresponds to our y value. So that means I'm going to be looking at our y-axis right here, and I'm going to be marking in 1/2. So that's going to be right here. Then I can say to myself, well, I'm going to be looking for this right here, this angle right here, and as we know, this is going to be the coordinates. The y value is a half, and I'm also going to be looking at this angle right here. And we know that the coordinates here, we don't care about the x, we just care about the y, it's going to be a half. And that's what we're doing. So we recognize that sine is telling us about our y value, and we just marked in where on the unit circle this a half is going to appear. And now what it's asking us to do is say, hey, can you find what this angle is? And yes, that's pi on 6. Can you find what this angle is? Yes, it's 5 pi on 6. And these right here are the angles for which these intersection points are going to occur. So these are going to be here. So in other words, sine of pi on 6 is going to be equal to a half, and sine of 5 pi on 6 is going to be equal to a half. So the final thing that you do here, the way that you write your answer, is saying theta is equal to, and then you write pi on 6 and 5 pi on 6. And that's really what we're doing here. That's the technique that we're using to answer these questions. We're going to be going through that a lot more in depth now, so let's go through it. All right, so here's the question again. And remember, the first thing you want to do when you're given this question is you want to look here and you want to say, well, let me just quickly grab the pen. I'm dealing with sine, and sine is all about my y-axis. It's sine of a half. Sine is equal to a half, so I'm going to mark in a half right there, and that tells me, let me see if I can do that a bit nicer. That tells me that I'm looking here, and I'm looking here. So in other words, I'm looking at my first quadrant because that's where that angle is going to appear, and I'm looking at my second quadrant because that's where this angle is going to appear, and that's where I'm going to get, a half out. So these angles here are a half. And as you can see, I just left the x blank because we don't care about it. We just care about that y. So hopefully that makes sense. These are the angles for which we're going to get a half out. Now, we need to figure out what the reference angle is going to be. So the reference angle is just the acute angle, or in other words, the angle in our first quadrant. Now, to find that out, you can use your special triangle, which is helpful at this point. So 2, 1, the square root of 3. Because I'm dealing with sine, I'm thinking of opposite over hypotenuse. So which angle will give me a half? This one or this one? Well, quite clearly it's going to be this one, which is pi on 6, because opposite over hypotenuse is a half. So pi on 6 is what I want. That's my reference angle. And then what I do is I just list out what the angles are going to be. So theta is going to be equal to, well, my first quadrant, that's pi on 6. And then my second quadrant, in my second quadrant, if this is my reference angle, I know it's going to be 5 pi on 6. Perfect. And that's how you would answer the first question there. Let's move on to our next question. The first thing you do is you look, whoopsie daisy. There we go. The first thing that we do is we look here, and we're dealing with cos. That tells me that I'm dealing with my x value. It's equals to a half, so I'm going to be right here. That's a half. So it's going to be here, this angle, and it's going to be, let me try that again, this angle. So I'm looking for this angle in my first quadrant, and this is my fourth quadrant, which is going to give me this angle right here. So those are the two that we're after. We need to find what my reference angle is going to be. Let's draw this out. Draw my special triangle. 2, 1, square root of 3. Because I'm dealing with cos, it's adjacent over hypotenuse. So that is going to be this one right here, because adjacent hypotenuse. This is pi on 3. So this is going to be pi on 3. And then what I'm going to do is I'm going to say, now this is x. So you have to always look at what your x is here. So it's going to be x is equal to, then I'm going to put in my first quadrant, pi on 3. And then my second, in my fourth quadrant, pi on 3 is going to end up being 5 pi on 3. So it's just really important that once you know your reference angle, that you're able to say, hey, my reference angle in this quadrant is going to be this. And that's where we stop. Now, the reason why we stop here is because, as you can see here, my domain is from 0 to 2 pi. And we have gone 2 pi, we have looked at just 2 pi around this unit circle to get our answers. If it asks for something more, that's when we would have to start thinking of doing more loops. But for this time, because it's just between 0 and 2 pi, we stop here. So that's really important that it's 0 to 2 pi. All right, we come down to our next question here. First thing we do, we look here. It's cos. Cos tells me I'm looking at my x. Then I look here. This is negative the square root of 3 on 2. Negative tells me that I'm over here. And it's going to be over here. That's going to be negative the square root of 3 on 2. So that means I'm going to be dealing with this angle and this angle right here. So that's going to be my second quadrant, and it's going to be my third quadrant. Now, once I've done that, I've got my first and second quadrant, second and third quadrant, second and third. I'm now going to figure out what my reference angle is going to be. As the instructions told us at the very start of this lesson, when we're finding the reference angle, you ignore the sign. So my reference angle, I'm just going to be looking for the square root of 3 on 2. Don't worry about that negative. So I'm going to draw this. 2, 1, square root of 3. And then I'm going to say, all right, I've got cos, so that's adjacent over hypotenuse. That's going to be this one, pi on 6, because adjacent over hypotenuse. So it's going to be pi on 6 here. And then once I've done that, I need to figure out what my theta is going to be. Now, as you can see here, my reference angle is not going to be one of my answers because I don't have anything occurring in the first quadrant. The quadrants I care about are the second and third quadrant. So if I have my reference angle is pi on 6, then in the second quadrant, it's going to be 5 pi on 6. And then in my third quadrant, it's going to be 7 pi on 6. And those are going to be my two answers. Again, I'm going from 0 to 2 pi. And 0 to 2 pi, so I'm just making one full rotation. The only time I'm going to get negative the square root of 3 on 2 are in my second and third quadrants, so I stop there. That's what that means. Perfect. Let's come over here now. Now, as you can see, this one's a little bit different. As you can see here, we're going to have to do some rearranging before we do anything else. So this isn't that tricky. All we're going to do is minus the square root of 3 to both sides. And now we're in the same position as we were before. But one of the steps in the procedure that we went through at the beginning of this lesson was sometimes you need to rearrange. So this is one of those instances where we have to do some rearranging before we can answer. So now we've got negative the square root of 3. Negative the square root of 3. Now, tan is a little different from sine and cos. You're not going to be thinking of your x or y. What I like to think in this instance is I'm going to be thinking of the gradient. Let's ignore the sign for the time being. Let's ignore the sign. The square root of 3 is the biggest tan value I can get. So I know it's going to correspond to here. And let me just walk you through how I think about tan. So I think about tan is I know I have 3 reference angles. The first one is 1 over the square root of 3. One is 1, and one is the square root of 3. Now, I think of tan in terms of gradient. So these are just 3 different gradients, and as my gradients are increasing, obviously these numbers increase. So this is the biggest gradient you can have, is the biggest tan value you can have. That's how I think about it. So when I'm given this question, I can immediately tell you that my reference angle is going to be, this is going to be pi on 3. So I don't even use my special triangles. I know that it's going to be my biggest angle, pi on 3. And now I need to figure out what quadrants this is going to exist in. Now remember, it's negative the square root of 3. So let me get rid of these. It's going to be here and here. Those are the quadrants that I'm dealing with. So I'm dealing with this angle and I'm dealing with this angle. So it's the second and fourth quadrant. So I now am going to list out what these are going to be. If this is my reference angle, in my second quadrant, that's going to be 2 pi on 3. And then in my fourth quadrant, that's going to be 5 pi on 3. And those are going to be my answers. Hopefully that made sense about tan. Think about it in terms of gradient. Everything will make more sense. All right. Okay, so these are some disgusting questions now, because as you can see, same process, but now we've just got degrees. And as time goes on, you'll love to learn radians more than degrees. First thing we have to do is we have to do some rearranging first. So I'm going to get cos of theta, and I'm going to divide both sides by the square root of 2. So it's going to leave me with this, like that. And as you can see, I'm from 0 to 360 degrees, which is the same as 0 to 2 pi. This is the same thing. Now, when you're given something like this, 1 over the square root of 2, you could draw your circle, your special triangle, to help you out. But I just immediately know that my reference angle is going to be pi on 4. And remember, for this one, you're going to have to use your different special triangle. You're going to use this one right here, which is 1 the square root of 2, and then pi on 4, like that. And then you would say cos of which angle would give me 1 on the square root of 2. It's obviously going to be pi on 4, and you're done. But as soon as you see something like that, you know it's going to be pi on 4, and that's just going to save you a lot of time. Okay, so then I mark that onto my unit circle, and I actually skipped a step. So I would first mark it on. So it's going to be about here, because it's cos, so it's my x. So it's going to be here. Whoops, it's going to be here. It's going to be here. So I'm going to be looking at my second and my third quadrant. Second and third quadrant. If this is my reference angle, in my second quadrant, I know that this is going to end up being 3 pi on 4. And then in my third quadrant, in my third quadrant, it's going to be 5 pi on 4. And those are going to be my answers. And as you can see, my brain was just in radians, but that's not what the question was asking, was it? It's asking for degrees. So let's scratch that. You're going to have to say this is 45 degrees. And then we can't say it in radians. That was my bad. I was just thinking in terms of radians. We're going to have to now give our answer in terms of degrees. Now, I don't know about you, but many people find it more tricky to memorize, the different degrees of each quadrant. So remember, we can kind of utilize what we know, and that is, here is pi minus theta, which is 180 minus theta. And then down here, it's pi plus theta, or in other words, 180 plus theta. So with that information, we can now say, well, for my second quadrant, it's going to be 180 minus theta, so 180 minus 45. And then it's going to be, for my third quadrant, 180 plus 45. So that means what my answer is going to be now is 135 degrees. And then over here, it will be 225 degrees. So really important, let me just stop here for a moment. You have to take note of the fact that we're dealing with degrees here. We're not dealing with radians. So my mind just immediately went to radians. And that means we have to give that. And also, I find it trickier to just memorize a whole bunch of random degrees like this. It's not that hard. If I put some effort in, I probably could just sit down one day and memorize them. But as long as you know these, you're home free. You'll be able to answer them really quickly. So just make sure that you know these things right here, these symmetry properties, which will really be handy. Okay, last one. What are we going to do here? First things first, let's rearrange. Oh, it's degrees again. Now, this right here, this is the same thing as 1 over the square root of 2, and it's a minus as well. It's the same thing. One is just the rationalized form, and one isn't the rationalized form. So you just have to kind of get your head around that. We're dealing with sine, so that's my y-axis, and it's negative, so it's going to be down here. So I'm dealing with here and here. So that's my third and fourth quadrant. Now, it's in degrees again, so I'm going to remember that here is going to be 180 plus the angle, and here it will be 180 minus the angle. Because it's going to be 360 minus the angle. Because remember, here it's 2 pi minus the angle. That's our symmetry property. So just memorize your symmetry properties. We have to now find my reference angle. Again, because I'm dealing with this, I immediately know it's going to be pi on 4, which is 45 degrees. I did it again. I just think of radians. And now I have to figure out what theta is going to be. Because I'm in my third quadrant, one of them is going to be 180 plus 45. And then in my fourth quadrant, it's going to be 360 minus 45. And now we just have to figure out what these are going to be. It's going to be 2, 2, 5 degrees, and this one will be 3, 1, 5 degrees. And those are my answers. So as you can see here, it's really important that you take note of the fact that we're dealing with degrees. We immediately knew that when we've got this right here, ignoring the sign, our reference angle is going to be 45 degrees. We also gave it a little bit of a sketch on our unit circle to figure out which quadrants we're going to be in, and that's really it. It's important to note that when you're doing these questions, you're not going to be given unit circles. I've just given you unit circles just to kind of help you out, but really important for you to realize that in these questions, you're not going to be given unit circles, but they are handy. Okay, with that, that is the first part done. I will see you in the second part.